Today we're going to start taking a look at the tangent form. So if you remember, going back to our unit circle, in our tangent, if we were to draw a line here to point P, and we always drew it straight on down, we always said that this was x, y, and 1. So our tangent down here, one way to write it would be opposite over adjacent, y over x. But if you remember, our x was our cosine for our unit circle, and our y was our sine. So it could be the sine of theta over the cosine of theta. If I was to put a little theta right in there. Now when you think about that, that's rise over run. That's also the slope then of this terminal ray. And our terminal ray just being that line right here. And remember, we can't have 0 on the denominator though. So our cosine cannot equal 0 because you can't divide by 0. So in the xy plane, an angle in standard position has the measure of pi over 3. What is the slope of the terminal ray? So this is pi over 3. So this would be root 3 over 2 and 1/2. So y over x, root 3 over 2 divided by 1/2. So when we divide fractions, we keep the top, change to multiplication, and we flip the bottom. So it would be root 3 over 1, which is root 3. So finding the tangent is the same as the slope of the terminal ray. So all of these, for example, if we needed to find tangent of pi over 4, so here's pi over 4. We know opposite root 4 is root 2 over 2. So y over x, root 2 over 2 divided by root 2 over 2. Well, that's just 1. Then we have the tangent of 5 pi over 6. So 5/6 pi, so that would be in this quadrant. So we have pi over 6. So opposite that is half. Opposite pi over 6 is half, so this means this is root 3 over 2, and I'll say negative. So we have opposite over adjacent, y over x. So again, keep the top, flip the denominator. And now here's what happens is 1 over negative root 3. We're going to rationalize this. So times root 3 over root 3. So this is really root 3 over 3, negative root 3 over 3. Because rationalize it gets us rid of the root in the denominator. And then 3 pi over 2. Let's see, pi over 2 is up here, so 3 of those. So this is the coordinate 0, negative 1. And again, it's y over x. So negative 1 over 0, we can't divide by 0, so we say that's undefined. So now we're going to take a look at what happens as we're going around this unit circle. So our slope here, it starts, because again, tangent is our slope, or we could think of it as y over x. So that's 0 over 1. It starts at 0. And then if I start drawing in all these lines, it keeps getting steeper and steeper and steeper until it gets up here, where it's straight up and down, where our slope is undefined. I should say it gets larger and larger until it approaches up here, which we know is the angle, pi over 2. And at that angle, it is undefined. Right? Because these are all, we'll notice these are all positive slopes. And they're getting steeper, right? Well, then it turns, right? And it's a negative slope. As it goes back towards 0, it's getting less negative until we reach right here. So at pi, you're back at a slope of 0. And then as soon as we pass pi, you'll notice our slopes, right? Aren't they the exact same thing? Right? As it was in quadrant 1. So every pi of a function, it starts to be the same slope. So our period is pi. So looking at this next one here, each time that the cosine of theta equals 0, the tangent is undefined. Because that's right, we can't divide by 0. Because sine of theta over cosine of theta. So where is it undefined? Well, where is our cosine 0 is here and here. So it's undefined at pi and 3 pi over 2. Well, do you guys remember we talked about this before? When you can't divide by 0, that's where there's a vertical asymptote in denominator, right? Oops, remember from last unit when we did those rational functions? Like if we had this, we said like x equals 3 is a vertical asymptote because 3 minus 3 is 0. So there's when we're graphing this, there's a vertical asymptote at pi and 3 pi over 2. All right, so at pi, wait, not at pi, sorry, this is pi over 2 and 3 pi over 2. So here is a vertical asymptote, 3 pi over 2 is a vertical asymptote, and then it would be going the other direction. And you'll notice the distance between those, and I put this in the wrong spot, I apologize. So at pi over 2 and 3 pi over 2, and the distance between those is our period of pi. So a little bit more about those vertical asymptotes. For the graph of the tangent of 0, theta, it's always at pi over 2, and then every period there's another one, right? Because we said our period, tangent starts to repeat itself after here. So every pi, it's undefined, right? Now if we change our period, so if you guys remember our period for sine and cosine, our period equaled 2 pi over b because it was a full circle before they started to repeat itself. For the graph of tangent of b, a vertical asymptote appears at pi over 2b. And it repeats every pi over b for the integer value. So if we're looking at a couple of these, let's first identify our period. So our period equals pi over b, so that would be pi over 2. And our vertical asymptotes, we can use that formula. Pi over 2 times 2 plus pi over b, that's our period right there. So we have pi over 2, k. So this is really pi over 4 plus pi over 2k. So our next period here, again, pi over b, so that's pi over 2/3. And again, so that's pi times 3 over 2. So we have 3 pi over 2. That's our period. Because again, as a reminder, it repeats every period here. And I guess I forgot to write that in there. I mentioned our period is pi over b. Sorry about that, you guys. So our vertical asymptotes, where are they? They are at our theta pi over 2 times 2/3 plus our period, which we said was 3 pi over 2b. So what is pi divided by 2 times 2/3, okay? So well, that's pi over 4/3. So what is that? That's pi times 3/4. So that means it's really 3 pi over 4 plus 3 pi over 2k. I don't know why I put a p there. That should be a k. I apologize. All right, so here's our graph of the tangent. You can see we have our asymptotes dashed in at pi over 2, and then every pi, right? And again, where does its tangent start at? Right here. So y over x, 0 over 1 is 0. So it starts at 0. And then we said it slowly gets steeper. So as you can see, it's going up. And then if we went the other way, it's negative, slowly going back towards undefined. So it's always increasing. Its graph changes from concave up to concave down between each set of points. And that's called the inflection point. So it's concave down, zoop, switches to concave up. Okay, and then the last thing that we are going to talk about on this last page. You can move these around like you normally would, right? So A, you have your B and your C and your D. So the constant A, just like on sine, it was our amplitude shift. This is a vertical dilation. So it does get higher faster. It's just really high to see. So the next thing is if A is less than 0, there's a reflection over the x-axis, okay? So That is our reflection over the x-axis. All right, so the next part is the constant b. What that is that's our period change. So our period change is pi over b, right? And it changes by the factor of 1 over b. So all we need to know is that's our period change, okay? And if it's a reflection, if it's negative, it's a reflection over the y-axis. The constant c creates a horizontal shift. So that will move it left or right, just like before. And then d creates that vertical shift. All right, so if we were to take a look at the graph of this, the first thing we do is have to factor out that b. So 1/2 the tangent of 2 theta minus, we have to multiply it in our denominator, pi over 4 plus 1. So our period, pi over b. So that's pi over 2. Our vertical asymptotes, pi over 2b. So that's pi over 4. 2 times 2 is 4. And then it's every period, so every pi over 2k. So what I'm first going to do is I'm going to write where would these be. So it would be at pi over 4. So it would be here and here. And then every pi over 2. So every 2 tick marks, right? Now what happens to these? They move to the right pi over 4. So right 1 mark. So if I move this one over, I could dash something in here, move it over. And so we can see now every other one, we're going to have this mark. And then what happened? How can we find it? Well, it usually crosses at 0, but now it's going to cross at 1. Okay. And then it shoots up and shoots down. Shoots up and shoots down. All right. So let's take a look at one last one here. If we factor out the half, -3, the tangent of half theta plus, we have to multiply it in the denominator, so half of 2 is 1, so pi over 1 minus 2. Okay, so what is our period here? Pi over b, pi over half, so that's really 2 pi. And then our vertical asymptotes, pi over 2b, and b is half, so it's just at pi plus every 2 pi. So it starts at pi, right? And then it's every 2 pi, which would shift off. But this moved to the left pi. So this one would shift here. So the left pi, it would shift here, which means another one every 2 pi would be right here. So our vertical asymptote, where is it at? It's at -2, a vertical shift. But you'll notice this negative. So instead of a swoop going up, it's a swoop going down.